Hello and welcome to Sudoku. Here is a coded pointing even Sudoku that was created by Hungarian author György Herke, and it has a really beautiful design with all these letters spelling Hungary and those digits spelling 2021. And the rule is that in a pointing even Sudoku, all the digits you see there just tell you how many even digits are to be seen in the direction of the arrows, or more precisely, how many cells containing even digits are to be seen. And those letters, which are 7 different letters, are coding 7 different numbers. And it's part of the puzzle to determine which letter corresponds to which number. And this is really fun, I think. And it was a lot of fun to test solve this puzzle. It was a long time ago. I don't quite remember the solving path, and I know it will be fun finding it again. Well, the first thing I notice is this 0, which will be very useful because we now know that all these digits are odd. So this is 3, 7, or 9. This is 1, 7, or 9. This is 3, 5, or 9, sorry. This one is 1, 3, or 9. And this one has 4 possible values, so I don't usually pencil mark 4 values, but now I do. Another option would be to write O or E in a corner to say that this is an odd digit, this is an even digit. It can be very useful in some other kinds of puzzles like Battenberg's, for example. So that's the first thing. And here is something interesting as well. This one points to this 8, so this must also be an odd digit. And this has been used, this has been used. So I circle them so as to remember that I don't need them anymore. And this too says that one of these 3 cells exactly contains an even digit. And I think it's too soon to determine which of them. Well, this too doesn't say anything right now. Okay, what can we do? So I think we could have a look at classic Sudoku as well. This 7 and this 7 say that there's a 7 in one of those cells and a 7 in one of those. Those 7 say there is a 7 around here, but I don't think we can do much. Oh, actually those 2s and 4 and 8 are not here, so these digits are 1, 3, and 6. Not sure it's very useful to pencil mark them. Now let's have a look at the letters outside. And we can see that some of them are really constrained. For example, this N can be at maximum 2. So it has to be either 0, 1, or 2. Don't forget that 0 is a number. This G points to at most 3 even digits. So that's 0, 1, 2, or 3. Well, this A is at least 3. And at most 7. So lots of options for now. This U has a maximum of 5 because of this 5. This H has a maximum of 3. This R has a maximum of 2 because there are already 2 and 4 in this box. And now you see something really interesting, that those 4 letters represent numbers between 0 and 3. And we know that all letters represent different digits. So 0, 1, 2, and 3 must be here. And this one can't be 0, 1, 2, or 3, so it has to be 4 or 5. And this one is at least 4 now. Y is remaining, and because of this 5, it can't be more than 5. And because of this, it can't be more than 4 actually. This is an even digit, this is an odd digit, sorry, so there has to be at most 4 even digits. And we know that 0, 1, 2, and 3 are not available, so Y is a 4 and U is a 5. And this A must be at least 6. So it has to be 6 or 7. Okay, so that's very nice. We now know that those 3 digits must be even. This one can only be a 4. This one can only be a 6. And this one can only be a 2. Okay, so now there must be a 2 in one of those cells. Do we get any consequence? There must be a 6 here. Well, that's not very useful. This 5 is very powerful. Those 4 cells must have even digits. So this one can only be a 2. So that's a 2. Those ones, here we have 4 or 8. Here this is 2 or 4. This one is 4 or 6. And this U is now satisfied. This 2 is important because now this 2 is fulfilled, and we know that the remaining digits must be odd. This one can only be 1 or 3, and 5 or 9 for this one, because of the other odd digits that can be seen from this cell. On this column, 4 can only go here. And now this is an 8. This 2 already sees this 4. But that's not so interesting. Oh, here 7. 7 goes into this cell. And up there, the corner notation gives us this 7. We know that there must be 6 or 7 even digits here. Oh, look, 6 can only go here. So we already have 6 even digits, and whatever goes into this, well, this A will be satisfied, so that's not very useful. 6, 6, that's a 6. 6, 6, there must be a 6 in one of those cells. What now? We still don't know how to resolve this. Oh, 8 and 6. So this can't be a 2 or a 4. It can still be an 8. But we sure know that G is neither 0 nor 1. Here, only 8 is available, so this one can't be a 2. Can this be a 3? We could get 6 here, 4 and 8 there. That looks possible. Could this one be 3? With an 8 here, it would work. Okay, let's have a look at those. 8 is not here, could still be in any one of those cells. So now those are 3, 5 and 9. Because of this 9, this is 3 or 5. This is 3, 5 or 9. Actually, 5 doesn't go in those cells, so 5 must be down there, and this is a 3. And this is not a 5, it must be 8 or 9. What do we get there? 2 is not here, no there, that's a 2. 3, 4 and 9, 4 is not here, no there, so 4 is here. That's a 6, and it makes this a 6. So this is not 0. 0 can still be here, 0 can still be here. Where should I look? 1, 3, 9. So this is a 3, 9 pair. 1 or 3 here because of this 9. 3, 9 and 5 on this row because of those digits. That's a 5, and that's 3 or 9. Oh, by Sudoku, that's a 2. And 4 must be in one of those. Well, I just pencil mark it. 7, 7, yes, this pencil mark disappears. We still need, this can only be 1 or 9. 1, 5 or 7. I'm getting slow now. This 4 is not here, it has to go there in the column. 6 is not here, 6 is not here, 6 is there. One, 3 and 8, that's not an 8, this is an 8. And now this is not 1, this is 2 or 3. So H and G are 2 and 3, so this one is 0 or 1. Next, what do we have? This can still be a 4. This is 1 or 3. And we get an 8 here. In this column we need 1, 3. Oh, this 2 puts a 2 here. It's been hiding there for quite some time. 1, 3 and 9 in this column, so this is 3 or 9. 1, 3 or 9. There's still the issue of the 8. Oh, this column needs a 1 and a 4. Oh. That's still not quite there. 3. 3 is up there. Oh yes, that's it. 3 is up there. So I don't get a 3 here, I get a 3 there. And 5, 8 or 9, so this is 8 or 9, this is 5, 8 or 9, obviously. 1, 3. 3 is not available. 9 is not available. This is 1 or 7. This is still very slow. And there's something going on here. I mean, if this is an 8, then R is 1, so N has to be 0, and this must be a 1. So 8 here makes this a 1. 9 here makes this a 1, which doesn't look that helpful. I must be missing something deep here, or no, or just something easy that I don't see. So we need 1, 5, 7, and 8 on this row. So this one is 1 or 5, yes? Okay. So this 8 should be more conspicuous. Now there must be an 8 somewhere here. Is it there? If 8 is here, that's something fun. If 8 is here, then this becomes a 3, and this becomes a 2, and this won't be 4. I don't think I need to do something so complicated. 1, 5, 7, 8. There's something between those two. So either there's a 4 here or an 8 there. Only one of them is 1. But I can't have both 4 and 8 here. How do I use such a bizarre constraint, such a weird constraint? I'm not sure about this. But then... oh, these two. That's it. These two sees both 4s here. So the remaining digit on this diagonal must be odd. So this one is odd, but I already knew that because the 8 is up there. So I already knew that this had to be odd. But this one now can't be a 4. So this is a 2, and that's a 3. So this is an 8. That was the missing piece. Very well hidden. So that's a 9, that's an 8. And now this is a 1, and this is a 0. So this is a 1, that's a 5. And what do I get? That's an 8. So this 0 is fulfilled, this 3 is fulfilled, this H will be fulfilled once I place this 4 here. And now we get a 3-4 pair. It's still not over. Well, 59 points is very, very underrated in my opinion, but I may just be very slow, to be honest. And wow, now I must be very tired of all of this. I can't find anything more. So those are 1, 5, and 7. 7 is not here, 5 is not here, so that's a 1. This is not a 1. That's a 1. It's the only place where 1 can go in this box. So this is 3, that's a 9. That's not 9. That's not 3. Oh, this one here. Oh, how I keep missing those. So there are lots of, well, puzzle is starting to collapse. That's a 3, that's a 1. Now, this one is a, yes, this one is a 7. That's a real 7 now. These digits are 3 and 5. And it's not quite over. Those ones are 3, 9, and 4. So this is 3 or 4, 3, 4, 9. And this 9 gives this 3, and this all works perfectly. Here we need a 1. A 1 is here. This is a 9, that's a 5, that's a 9, that's a 5, a 3, a 5, and the last digit is a 3, and it all works fine. And this was a 7, by the way. So this really was no easy puzzle, but it was really beautiful both visually with this theme, Hungary 2021, and the logic in it was very good as well. Thanks for watching this video. See you soon on Sudoku.